Hello friends, in this lecture we are going to discuss the second type of centrifugal governor, which is Porter governor. The Porter governor is the modification of Watt's governor. You can see a small change in the whole arrangement of this Porter governor. You can see a central load along with the sleeve in this arrangement, but other parts are more or less similar to Watt's governor. And you can also see the line sketch of the Porter governor. So the various terms which are related to this Porter governor, the first one is M, that is mass of the governor, which is specified in kilogram, then W is the weight in Newton, and capital M is the mass of the central load in kilogram, and capital W is the weight of the central load in Newton, and R is the radius of rotation in meters, and H is the height of the governor, and capital N is the speed of rotation of the ball, and Fc is the centrifugal force acting on the ball. Now we can see the various formula used for solving the Porter governor problem. So here capital N square is equal to small m plus capital M divided by 2 into 1 plus Q divided by small m into 895 divided by H. Here the term Q represents tan beta divided by tan alpha, which is nothing but the angles are taken from the line sketch diagram. So here you can see the value alpha is the angle between the central axis and the arm, which is taken as alpha, and beta is the angle which is between the link and the vertical axis. And if the length of arms are equal to length of link, the value Q will disappear. So we can write the same formula as N square is equal to M plus capital M divided by small m into 895 divided by H. The same formula if we are considering the friction. Normally friction is specified in Newton. So in this situation we can use the following formula, which is N square is equal to small mg plus capital Mg plus or minus F divided by 2 into 1 plus Q divided by Mg into 895 divided by H. So here if you use the Q value as 1, that is whenever the length of the link is equal to length of the arm, the value Q will become 1. That time the formula can be reduced to mg plus capital Mg plus or minus F divided by small mg into 895 divided by H. Now we can solve an example problem related to Porter governor. The Porter governor has equal arms of length 250 mm and pivoted on the axis of rotation. Each ball has a mass of 5 kg and the mass of the central load on the sleeve is 25 kg. The radius of rotation of the ball is 150 millimeters. When the governor begins to lift and 200 mm when the governor is at maximum speed. Find the minimum and maximum speed and range of speed of the governor. So in this problem, you can see the given data. The length of the link and length of the arm both are 250 millimeters. Then mass of the ball is 5 kg. Mass of the central weight is 15 kilogram. R1, that is the radius of rotation at its minimum speed, and R2 is the radius of rotation at its maximum speed. Then here, as it is mentioned, length of the arm is equal to length of the link. So we need not consider the value alpha and beta. So both will be equal. So we need not consider the term small q, which will automatically get cancelled. See here, first we have to find the value of h1 for the speed, which is the lower speed or minimum speed. So in the minimum speed condition, we have to calculate the value h, which is specified as h1. So h1 can be calculated using the trigonometry relation. So we can write Pg is equal to square root of Pb square minus Bg square. When you substitute the values, you will be getting 0.2 meter as h1. So if you substitute this value in the n square equation, you can substitute small m value, capital M value and h1 value. You will be getting the n1 square value as 17,900 and n1 value is the square root of that n1 square value, which is equal to 133.8 rpm. In the same way, we have to calculate the maximum speed when the radius of rotation is 0.2 meter or 200 millimeter. So same way we have to calculate the height according to the maximum speed, and using the same relation we can calculate the h2 value. So when you substitute the known values, that is small m, capital M and h2 value, which is just calculated, you will be getting the value of n2 square. By taking square root of this value, we will be getting the n2 value, which is equal to 154.5 revolutions per minute. Then for calculating range of speed, we have to calculate the difference between the n2 and n1. Here n2 is 154.4 rpm and n1 is 133.8 rpm. The difference is 20.7 rpm. We'll solve one more problem from this Porter governor. So here the arms of a Porter governor are each again 250 mm long and pivoted on the governor axis, that is the vertical axis. The mass of each ball is 5 kg and the mass of the central sleeve is 30 kg. The radius of rotation of the ball is 150 mm when the sleeve begins to rise and reaches the value of 200 mm for maximum speed. Determine the speed range of the governor if the friction at the sleeve is equivalent of 20 Newton of load at the sleeve. So here you can just see the given data. The length of the arm and length of the sleeve both are same, 250 mm. Then mass of the ball is 5 kg and mass of the central load is 30 kg and radius of rotation at minimum speed is 150 and at maximum speed is 200 mm. And here the friction at the sleeve is given as 20 Newton. So we have to consider that when we apply these values in the equation n square. So first we will calculate the height h1. So h1 is the height which is equal to the height of the governor when the speed is at its minimum. So here the radius is given as 150. So the h1 will become 0.2 meter. So when you substitute these values in the equation, n1 square is equal to mg plus capital Mg minus f divided by mg into 895 by h1. So here we are considering the friction value as minus 20 Newton. So here ensure that all the values are substituted in Newton, not in kg. Since the value 20 is in Newton, you have to convert all the kilogram values into Newton by multiplying it with 9.81. So the value n1 square becomes 29,500 and n1 will be 172 rpm. Same way we can calculate h2 for maximum speed using the same relation, and we'll be getting the h2 value as 0.15 meter. So by substituting that in the equation, n2 square is equal to mg plus f. See here in the first formula, when the lower speed, we are substituting the friction value as negative value, but here it should be positive. So divided by mg into 895 divided by h1. So when you substitute all the values in Newton, we'll be getting the N2 square value as 44,200 and the N2 value is 210 rpm. So now the speed range of the governor can be calculated by taking the difference between N2 and N1, which will be equal to 38 rpm. Thank you.